Today we're going to solve another problem using vector addition. We're going to use the algebra and trigonometry method and the 6-step process. So let's go ahead and begin. I've already drawn the diagram up here. In fact, the diagram was actually given in the question. And the question was, a person walks the path shown over here. At the end of the walk, what is the person's resultant displacement, both magnitude and direction, measured from the starting point, right? So here's one vector, here's another vector, here's our third vector, and our fourth vector. This is going to be our resultant vector, and we want to find both the magnitude and the displacement. I've already defined the directions, and again, it really doesn't matter what you make positive, left or right, up or down. I decided to make to the right positive and make up positive. That means the other directions are going to be negative. And I've already written the steps, so step 1 is kind of already done for you right here. Step 2 is resolve, step 3 is data table, step 4, draw a new triangle, step 5, Pythagorean theorem, and step 6, find the angles. So we're going to go ahead and we're going to kind of fill that in for you. So let's get started. Step 1's already done. Step 2, that's where we're going to actually resolve. So vector number 1 is already in the horizontal direction. So any vector that's totally horizontal or totally vertical, it's kind of already resolved for you. You're all set. What you got to worry about is any vector that goes off at an angle. Those we actually have to resolve. We have to break those vectors up into their horizontal and vertical parts or components. So let's go ahead and do that. So what we need to do is create right triangles in order to do this. So let's take a look at the second vector right here. I need to resolve that into its horizontal and vertical components, or its x and y components. So I want to find, what's the horizontal part of this and what's the vertical part of this vector. So let's go ahead. I'm going to use blue and we're going to kind of trace that out. So the horizontal part, and again, I like to actually include my angle within the triangle. So here's my angle that I was given. So I want to make a triangle using this angle. So I'm going to extend this side lengthwise, right here, horizontally. And the bottom of this vector right here, so I'm going to kind of go up, and it looks like I overshot the mark a little bit, so I'm going to erase a little bit of that. And then I'm going to go straight down. And I want to create a right triangle. Notice I got a right triangle there that includes my angle. So I want to find the horizontal component, and I want to find this vertical component. And I'm going to use the trig function sine and cosine to do that, because I have the hypotenuse and I've got the angle. So I need to find the opposite side, right? Opposite the angle. The opposite side is my y component, and the adjacent side is going to be my x component. So let's go ahead and do that for this triangle. So let's start, I guess I'll start with the adjacent side. So I'm going to go ahead and I'm going to use cosine for that. And I'll put a little x because I'm looking for the x component of this blue triangle right here. So cosine theta equals adjacent over the hypotenuse. Cosine 47 degrees equals the adjacent side over 8.5 meters. And then I'm just looking for that adjacent side. So that comes out to be 5.797. So 5.797 meters. All right, now I want to find the y component. So I'll put a little y there. And the y component is it's opposite the angle. So I want to use sine for that. So sine theta equals opposite over hypotenuse. Sine of 47 degrees equals the opposite side over 8.5 meters. And the opposite side, which is my y component, is going to work out to be 6.217 meters. And I'm going to go ahead and I'm going to underline that, and I'm going to underline that. That's important information. I'm going to use that later. All right, let's go ahead and do this for our next vector, which is this one right here. So this is the angle I was given, so I like to include that in my triangle. So I want to find the horizontal part of that, which is this, and I want to find the vertical part of that vector, which is this. So I'm going to go ahead and I'm going to extend this. I'm looking for the horizontal part, there it is, and the vertical part is going to be that right there. So X and Y. And notice I've got a right triangle. You always want to create right triangles. So let's go ahead and, I guess I'll do the X component. I'm going to use cosine for that. So I'll put a little X up here. Cosine theta equals adjacent over hypotenuse. Cosine of 32 degrees equals the adjacent over the hypotenuse, which is 4.8 meters. And then the adjacent side is going to work out to be 4.0706. 4.0706 meters. And I'll underline that. And now let's go ahead and deal with the Y component. Notice the Y component in this case, again, is the opposite side. So I want to use sine to figure that out. Sine theta equals opposite over hypotenuse. Remember, I've got the angle, I've got the hypotenuse, so I can solve for that opposite side. Sine theta, or sine 32 degrees, equals the opposite side over 4.8 meters. And then the opposite side is going to work out to be 2.5436. 2.5436 meters. Again, I'll underline that because that's going to be important information. And what I have done so far is I have resolved any vectors that kind of go off at an angle. I've found the horizontal and vertical parts of those vectors. Now what I want to do is I want to go over to my data table. So I'm going to create a data table, an X and a Y. And I want to add these, I want to add up the X components, and I want to add up all the Y components. So I start at the very first vector, which is 2 meters. That one's totally horizontal. And it's also going to the left. Remember, I made right positive, so that's going to be a negative 2.0 meters. So negative 2.0. And the Y part of it is just, I'm going to put 0. Some people leave it blank, but I like to put a 0 there so I know I'm not forgetting anything. So I'm going to put a 0 for the Y component because there is no Y component for that vector. Now let's go to the second vector, this one right here. Right? So the horizontal component is 5.797, and it's going to the right. And I made to the right positive. So this is going to the right. Right is positive. So I'm going to go ahead and I'm going to write a positive 5.797 in there. The vertical component is going down. Remember, I made up positive, so down is going to be negative. So I'm going to go ahead and put in a negative 6.217 meters. Now I'm going to go ahead and I'm going to address the third vector, this guy right here. Here's the horizontal part, here's the vertical part. Both are going in the positive direction, right? The horizontal part is going to the right, which is positive, and the vertical part is going up, which is positive. So I'm going to put two positive numbers, positive 4.0706 and positive 2.5436. Now the last vector is all vertical, so that makes things easy for me. It's going in the up direction, so I made up positive, so I'm going to put a positive 3.2. Remember, it's vertical, so a positive 3.2. And then there's no horizontal part to this at all. So again, just to make sure I deal with everything, I'm going to put a 0 in there. And now I'm going to go ahead and I'm going to add up all the x's, and I'm going to add up all the y's. So let's go ahead and do that. So when I add everything up, I get 7.8676. I'll put a little circle around it. That's important information. And over here, I get negative 0.5 0.4734. Now those are two important numbers. So when I add up all the x's, I get that. When I add up all the y's, I get that. I'm going to use those two components to now build a new triangle. A new triangle that should represent this right here. So I'm going to go ahead and I'm going to draw an x and a y axis. I'm going to start right there. In fact, let me move that over just a little bit so I don't run out of board. And I'm going to move that over right here. This is my origin. This is where I'm going to start. And I always address the x component first. Always. So I made right positive. This is a positive number. So I'm going to go to the right that far. Let's assume that that length represents that number right there. And I'm going to go ahead and I'm going to label that. So that'll be the x component, 7.8676 meters. And notice my y component is negative. Up is positive, so I'm going to actually have to go down. Now when I draw this y component, I want to draw that at the tip of the arrow that I just drew. So I'm going to go to the end of this x component right there, and that is where I'm going to draw this y component. I'm going to go down just a little tiny ways, 0.4734, not much. And maybe I'll draw that just a little bit more vertical. There we go. And we'll label that negative 0.4734 meters. Now, I'm going to go ahead and draw my resultant. So I go to the beginning, where I started. I go to the end, and I want to connect those two. That's my resultant. So if I can figure out that distance, that's my magnitude, and then my angle would be right there. Again, usually we like to make the angle relative to the x-axis. Not always, but usually, and I'm going to do it here. So I'm actually going to have a negative angle because I'm below the x-axis. Right, well, let's go ahead and finish this off. So in order to find this resultant, this magnitude right here, I'm going to apply the Pythagorean theorem. So c squared equals a squared plus b squared. That's my original equation. And a and b are going to represent the legs of the triangle. So there's one leg, and there's another leg. So I'm going to go ahead and I'll put my x component in for a, 7.8676 meters. I'm going to square that, plus my y component, negative 0.4734 meters. And I'll square that. Then I need to take the square root of the whole thing to get c all by itself, because I want to go from c squared to c. And I'm going to round off to two significant digits, 2, 2, 2. Everything in my original diagram has two significant digits, and I used all those numbers to get to this final answer. So I'm going to default to the rules of multiplication and division, and my final answer is going to have two significant digits. So I'm going to round off to two significant digits, and I end up with 7.9 meters. Put a little box around that. That's the magnitude. Now I got to go ahead and I got to find the direction, which is my angle. So typically we use tangent to do that, because we have the x component and the y component, meaning we have the opposite and the adjacent sides. So I'm going to go ahead and I'm going to use tangent. Tangent theta equals opposite over adjacent. Tangent theta, and I'm looking for theta, I'm looking for the angle, the opposite side, and I'm just going to put a positive value in here. When I use tangent, I like to use the positive values. So I'm just going to stick, even though that's negative, I'm going to put a positive value in there. Think absolute values. So I'm going to put 0.4734 meters over the adjacent side, 7.8676 meters. So I want to take that number and divide that into it, and take the arc tangent to get rid of this tangent, or on the TI-84 and TI Inspires, you're going to do what? Second tangent, and that's going to give you that angle. Make sure you're in degree mode, or this won't work. And I'm going to round off to 2 significant digits again, and I'm going to end up with negative 3.4 degrees. Now my angle actually comes out to 3.4 degrees, and I'm making it negative because it's below the x-axis. So that's going to be a negative angle. And that's going to be it for this problem.